Here is what happens if you integrate with the mainframe directly. Your shiny new service calls it, gets a record back, and now it has to do something with that record. The fastest thing, the thing that ships this sprint, is to keep the fields as they are. So your new domain object has a field called statcd because that is what came back. Then the next service reads from yours, and now it knows about statcd too. 6 months later, you have built a distributed system in which every service speaks the mainframe's language, and you have gained nothing except more network hops. You did not modernize anything. You made the mainframe bigger. And that record is not neutral data. It is 40 years of decisions you were not present for, fixed with fields, because it was designed when that mattered, dates that are 6 digits, or stored as an offset from a date somebody picked, a status column with 14 values, 3 of which are unreachable, 2 of which mean the same thing for reasons involving a merger, and 1 of which means yes for one product and no for another. None of that is documented. All of it is load-bearing. If you adopt that model, you have adopted every one of those decisions permanently into a system that is supposed to outlive them, and you will not even notice you did it, because each individual field looked like just a field. So you put a thing in between whose entire job is translation. It speaks the mainframe's language on one side and your domain's language on the other, and it is the only component in your architecture allowed to know both. Everything downstream of it receives clean domain events and has never heard of statcd. That is the anti-corruption layer, and the name is doing real work. It exists to stop something spreading. Notice what it is not. It is not a mapper you sprinkle into each service, because then every service still knows the legacy shape, and you have just moved the problem into a shared library. It is a boundary, singular, with a side that is legacy and a side that is not. In practice, it owns more than field renaming, and this is where it earns its cost. It owns interpretation, deciding that status code 4 and status code 11 both mean lapsed, and writing down why in code with a test. It owns the lies. When the legacy system returns a value that is technically wrong and everyone has silently compensated for years, the compensation lives here, once, visibly, instead of being reinvented in every consumer. It owns protocol. The mainframe is synchronous and batch-oriented. Your services are event-driven, and something has to bridge those without infecting either. And it owns being the place someone can read to find out what the old system actually does, which by the end of a migration is frequently the best documentation the company has. Now, it gets skipped constantly, and for reasons that sound good in a planning meeting. It is pure overhead, it adds no feature, and the first version is a lot of tedious mapping code for something the business cannot see. It is slower this sprint, definitively, and someone will point out, correctly, that you are duplicating the model and duplication is bad. But that argument is exactly backwards here. The duplication is the point. You are paying, once, to keep 2 models from becoming 1 model, because the one they would become is the old one. Skip it, and the cost does not disappear, it just gets paid later. By more people, in a system where the legacy shape is now in 20 services and cannot be removed from any of them. So the legacy model stops at the boundary, and clean events flow out of it. Except that raises a question I have been dodging. When your service updates its own database and publishes an event about it, what happens if one of those succeeds and the other does not? Next episode, the dual write problem and the outbox. See you there.